Welcome back. Today we're going to do section 4.1, which is the transformations unit. So we're going to talk about how we can sketch graphs without actually using our calculator based on what's happening to the parent functions. So up at the top we have our basic transformation formula. So if you'll look up here, you have y equals a times f times bx minus h plus k. Okay? So each of these values will give you a specific shift, stretch, or reflection. And you should know all the parent functions that we used from the unit before. So when you're asked to list transformations, these are the typical orders that you will do. So you're going to do horizontal shifts first, then you're going to do stretches and compressions, then we're going to do reflections, and then we're going to do the vertical shift. Okay? And one of the things I try to teach all of you, which will help you do these correctly, is to remember that when you're looking at a function, a parent function, and the numbers are inside with the x variable, then that number is going to affect the x value by whatever it says doing the opposite. Okay? So anything with x, you will always do the opposite of what you think you would do. Anything that's outside the parentheses or not inside with x, then that number will affect y, and it affects y in the exact manner that it says it will. Okay, so y does what it's supposed to, the x's do the opposite. So if you can try to keep that in mind, that'll help with the transformations. So the only transformation, the parent functions we're going to use in this section will be these listed here. So we're not going to do logarithms or exponentials or any of those, okay? So these are the parent functions for your transformations. So we did a few on the last set of notes. I kind of explained what happened. So today we're going to go through that and see why. So underneath there, you have just your basic table of what happens to each of your functions when you're making a certain transformation. All right, so just so you understand this. So you have your parent function. Now remember, these letters come from up here, okay? So when I'm talking about A, it's outside of the function f. B and h are inside with x, and then k is outside. So only B and h will affect the x value, A and k will affect the y value. So the vertical stretches and compressions are there for A. Okay, so the number A is going to affect how much you stretch your graph vertically. When A is bigger than 1, it's going to stretch it, and if A is smaller, between 0 and 1, then it kind of shrinks it down. The vertical shifts up and down are your K values. Okay. Then you're going to look at also a reflection. So if the A value or if the number outside happens to be negative, then it will also reflect over the x-axis. Same thing with your horizontal numbers, which are the B and the H. So the B and the H, you have your horizontal stretch and compress. Notice it's different. You're going to stretch it when B is a number between 0 and 1, and you're going to compress it when B is greater than 1. Remember, I told you, you will do the opposite, right? You're going to do 1 over B. And the same thing with your shifts, okay? You're going to go to the right when you see minus H. You're going to go to the left when you see plus H. So again, opposite. Now the only thing that remains the same is when x is negative, you're going to take the negative of x. You have to do that. That's the only thing you can do with a negative sign. But that will reflect you over the y-axis. Okay, so this is just kind of an organization for you so that you know how to do those transformations. So in the next few pages, we're going to do some of these transformations and see how they work. All right, so example 1 is just asking you what is similar about these functions and what is different. So what's similar about them is they all have the same transformations going on. They all say 5 times x, okay, and they all say minus 9. So these have their what's similar about them is that they're all performing the same transformations. Okay. What's different about them would be their parent function. This is the cube root of x, this is absolute value of x, and this is just function notation. So what's different are the parent functions. Now this leads me into a good thing about telling you that you do need to learn this, because you can put this in your calculator and get your ordered pairs. You can put this in your calculator, get your ordered pairs. You cannot put these in your calculator and get your ordered pairs and get your graph, so you have to be able to do the transformation like I'm showing you. So when we do these that you can use your calculator, that's fine to do it on your own and then use your calculator to check, but you have to be able to do them for the ones that are coming up that you can't put in your calculator. Okay? All right, so let's look at example 2. Here's our function, 3 times the square root of negative x minus 5. List the transformations in order. All right, so the first thing would be the horizontal shifts, which there are not any. Okay, that would be something plus or minus inside here with x. So we're not doing that. Then remember, after that, let me pull this back up, you're going to do the stretches, then the reflections, and then the vertical shifts. Kind of in alphabetical order, if that kind of helps you, okay? So now we're going to look at stretches and compression. That has to do with the numbers out front of x and y. So here's a vertical stretch of 3 to y, okay? So, vertical stretch. Things on the outside affect y. Then reflections. There's a negative sign. Negative signs are reflections on, when x is negative, that reflects on the y-axis. It does the opposite. Remember what you think, okay? Think about it on this graph. If I switch x from a positive x value to a negative x value, it's reflecting over this axis, which is the y-axis, okay? All right, then we're going to do the vertical shifts. So we have a vertical shift down 2. Remember what, 5. Where I got 2 from, sorry. Okay. So anything on the outside, we're going to go up or down, exactly what it says, so down 5. All right, so now the parent function. What is the parent function of this graph? That would be y equals the square root of x. So let's pick a couple points that we know on that. 0, 0, 1, 1, and 4, 2. Finally got that right. Didn't put a 2, right? So take the square root of those. So those are the parent. So I'm going to just dot that in. 0, 0, 1, 1, 4, 2. So here's the parent function. It's not our answer. That's the parent function. So here's the easiest way I can tell you this. Always look at the parent function, and then let's do what it says to do for x and y here. Okay? So the only thing that's happening to x is what's inside, which is taking the opposite. So I'm just going to write negative x. That's all that's happening from this x to this x. Now, 2 things are happening to y. We're going to multiply y by 3, and we're going to subtract 5 from it. So that would look like this, 3y minus 5. Okay? So again, things inside happen to x, things on the outside happen to y. So now, if you have that, and you know your parent function table, then all you have to do is work these problems out using these numbers. So this says take the opposite of x. So take these numbers, take their opposites. And that's it. Y, you got to do a little work too. For each y, you're going to multiply by 3 and subtract 5. So take 0, multiply by 3, which is 0, minus 5 will give you negative 5. Take 1, multiply it by 3. 3 times 1 is 3, minus 5 is negative 2. And take 2, multiply it by 3, which is 6. 6 minus 5 is 1. Now, when you plot those points, 0, negative 5, negative 1, negative 2, negative 4, 1. Okay, there's your graph. That's the real graph. And see what it did. It stretched this. So here's the regular graph. We took that and we stretched it. We made it go bigger. See, from here, we reflected this over the y-axis, which we did, and then everything went down 5. So these transformations should show up on your final graph. But by doing the parent function, I think it's real easy for you guys to get the graph. Because remember, Right now you can put that in your calculator and get these points out of your table, but not on the next few pages. Okay, so be careful with that. All right, let's look at example 3. Now we're going to do an absolute value function. Let's look at the transformations. All right, horizontal shifts first. So here's a horizontal shift. We're going to do the opposite. So this is a horizontal shift. And we're going to go right 1. We're going to do the opposite of -1. So you'd think you'd go left, but no, you're going to go right 1. Now we're going to do stretches. There's no multiply numbers out here, so there's no stretching going on. There is a negative sign outside of x, so this is going to affect y. So this is a x-axis reflection. Remember, the reflections do the opposite because think about it. If this is affecting y, take the opposite of y, then you're going from here to here, right? And that's reflecting over the x-axis. All right, and lastly, you have a vertical shift. We're going to go up 3. Okay, and that's it. All right, so now we're going to look at our parent function for absolute value. -2, -1, 0, 1, 2, just so you can see both sides. The absolute value of x is our parent function. Okay, that's the parent function. So this just means take the positive of each number. So 2, 1, 0, 1, 2. And remember, absolute value, the parent function is just a v. Okay, so that's the parent function. That's not our answer. All right, so now we're going to take each of our numbers and see what's happening to them on here. So here's your equation. What's happening to x? The only thing you're going to do to x is what's inside with x, and you're going to do the opposite, so we're going to add 1 to x. What's happening on the outside affects y, so we're going to take the opposite of y, and then we're going to add 3 to it. Okay? All right, so all we have to do to our x values is add 1. Add 1 to -2. Add 1 to -1. Add 1 to 0. Add 1 to 1. And add 1 to 2. Okay? For the y values, we're going to take the opposite of this number and then add 3 to it. Okay? So the opposite of 2 is -2 plus 3 is 1. The opposite of 1 is -1 plus 3 is 2. The opposite of 0 is 0 plus 3 is 3. Opposite of 1 is -1 plus 3 is 2. Opposite of 2 is -2 plus 3 is 1. All right, so let's see if our transformations are what we said was going to happen up here. So plot -1, 1, 0, 2, 1, 3, 2, 2, and 3, 1. So here's our final graph. Okay. Did it do what we said? Did we go right 1? Yes, we did. Did we reflect over the x-axis? Yes, we did. And then we took everything and went up 3. Okay? So you don't need your calculator, and you should not need your calculator, again, to do these transformations. All right? All right, next page, some more. So we're just going to practice this, and hopefully until we get really good at this. Okay? All right, so here's another one. This is a cube function, x cubed. So there's our parent function. Write that down now, x cubed. Okay? Transformations. Now, here's the thing. To be in with x, in this case, there would have to be parentheses. So this right here, okay, this would be the 1/4 would be inside with x, and it would affect x. This 1/4 is not inside with x, so this affects y, and so does that -2. So when I say it has to be inside with x, there has to be either parentheses or absolute value signs, something that is kind of keeping it together with x. So these are not the same. These are two totally different problems. Okay? This one affects x, this one does not. So that's not the one we're doing right now. So we only have two transformations. Both are affecting y. So the first one, this would be a compression, right? When this is your A value, when it's between 0 and 1, that's a vertical compression of 1/4, do exactly what it says to Y, and then this is going to go down 2. So this is a vertical shift down 2. Okay, so that's it. That's all that's going to happen. So x cubed, let's pick -2, -1, 0, 1, 2 again. Plot those points. Cube those numbers. -2 cubed is -8. -1 cubed is -1. 0 cubed, 1 cubed, 2 cubed. All right, I don't have 8 on here, but let me go ahead and put the rest, 0, 0. So I know this is the parent function, okay? That's the parent function. All right, so nothing's happening to x, so x is going to remain the same. What's happening to y? We're going to take 1/4 of y, and then we're going to subtract 2. Okay? So the x's remain the same. No transformations to those. We're going to take 1/4 of this number and then minus 2 from that. So 1/4 of -8 is -2, minus 2 is -4. 1/4 of -1 is -1. I'm sorry, is -1/4. So -1/4 minus 2 is -2 1/4. Okay. 0, 1/4 of 0 is 0. 0 minus 2 is -2. 1/4 of 1 is 1/4. So 1/4 minus 2 is -3 3/4. And 1/4 of 8 is 2. 2 minus 2 is 0. All right, so let's plot those points. -2, -4. -1, -2 1/4 is about there. 0, -2, 1, negative, and do that right. I can't be. Let me do that one again. 1/4 of 1 is 1/4 minus 2 is -1 3/4. Catch my mistakes. Sorry about that. All right, so -1 3/4. 1, -1 3/4. That makes more sense. And then 2, 0. All right, so there's my new graph. Okay. All right, so did it do what it said? Did we shrink this, compress it? Yes, we did. And then it just went down 2 units. So that's all that happened to that graph. So there's what it looks like. Okay. All right, example 5. This time they're going to give us the transformation. We're going to write the equation and then graph it. So we're going to use the parent function of x squared. And we want to shift it right 3 units. So this affects x. We want to do an x-axis reflection, which that affects y. And up 1, that also affects y. All right, so the only thing that's going to be inside with x is to go right 3. So we're going to do parentheses and x minus 3 squared. Okay, that's the only thing that affects x. We're going to go right 3. Remember, we do the opposite of that sign. X-axis reflection affects y, so that's a minus sign out front. And then up 1 also affects y, would be outside. Okay, so notice this is inside with x. Okay, all right, so pick some numbers for x squared. So I always use these numbers as long as it's just an easy function to do. So square those numbers. 4, 1. My dog just decided to come up here. Oh, yeah. Okay. Come up here. Sorry, guys. Oh. Joys of recording at home. All right, so there's your function. So let's write those numbers squared. He's got me all flabbergasted now. There we go. So square those numbers. Okay. So again, your parent function right here. All right. So there's the parent function, x squared. Okay. All right. Now, we're going to do what happens to x. So the only thing that affects x is we're going to go right 3. So we're going to do x plus 3. What's affecting y? We're going to take the opposite, and we're going to go up 1, plus 1. All right, so we're just taking the x values and adding 3 to them. So negative 2 plus 3, negative 1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3. So add 3 to those. Then we're going to do the opposite of y's and add 1. So the opposite of 4 is negative 4 plus 1 is negative 3. The opposite of 1 is negative 1 plus 1 is 0. Opposite of 0, 0 plus 1 is 1. Opposite of 1, negative 1 plus 1, 0. Opposite of 4, negative 4 plus 1, negative 3. All right, so let's plot those. 1, negative 3, 2, 0. 3, 1, 4, 0, 5, negative 3. So there's your new graph. Did it do what it said? Did we take this and go right 3? Yes, we did. We reflected over the x-axis, and then we went up 1. Okay? So there's that transformation. All right, so I'm going to stop here for part 1. You can work on some of your homework again if you'd like, or you can continue with me with part 2 and finish your notes. Sorry about the dog interruption. See you back here in a little bit.